And let me introduce myself. I'm Deepika. I'm being a software developer at CLAR Technologies Private Limited. And as you can see on the screen, I would like to present to you today is on the basics of blockchain. So we could have heard the word called ledger. Ledger is the system of records for a business. So multiple ledgers will be incorporated for multiple businesses. So over the years, these ledgers have digitized and transformed to fit into the needs of like today's necessity. So here comes a digital ledger, that is blockchain. The blockchain is exactly a digital ledger that is very much secure, immutable, and we couldn't able to manipulate anything by rewriting or erasure onto the blockchain. So a blockchain is a chain of blocks that contains information. So the data which we going to store into the blockchain depends upon the type of the blockchain. For example, if it is the transactions based on the Bitcoin, then it is then the data will be stored on the Bitcoin blockchain. Example for Algorand and Ethereum, it will be different. The key differences between centralization and decentralization. So in simpler words, if a single person or an authority who are in charge of planning and decision making of that particular network or an organization, we call it as centralization. Basically the fact of being centralized. On the other hand, in the case of decentralization, there is no such single authority or a single person who is maintaining it. Rather, it is the delegation of authority in that particular network. And in the case of centralized organization, it will have only formal communication. But conversely, in decentralization, the communication will be stretched out in all the directions, in all the nodes who are into that network. So key aspects of blockchain. First one is immutability. Immutable in the sense we can't able to change anything. In this way, blockchain is untamperable and permanent. The next one is decentralized. As we get rid of the centralized authority, no one can simply change any characteristics or any feature of the network for their own benefit. So this is actually a very much one of the key aspect. The next one is enhanced security. Every information we put into the blockchain will be hashed cryptographically. Like we use cryptography as a special disguise in the case of enhanced security. The next one will be distributed ledgers. Here the ledgers are replicated, shared, and synchronized across all the networks, all the nodes who participate into the blockchain. So here I would like to incorporate other network. I will be continuing as the word network and node. So network is probably a set of computers which is linked together in order to share the resources. The another term means a node. Each and every computer we connect into the network. All the other computers connected on that particular network, we call it as node. And the next one is consensus. Consensus in the sense a common agreement like between the nodes who participate on the network. So based on the common agreement, the blockchain network will be deciding the it will make the decision making process.
Hi, Deepika. Sorry, this is Shanmugam.
Yeah.
In the previous slide, can you just go to the previous slide? How? See, I understand the key aspects of the blockchain right here. How it's going to affect on the future on our day-to-day life. So how do you see that? How can I visualize it? Because this is purely from the technical perspective of it, right? How can I visualize? If I am a layman, how can I visualize this one?
Okay, shall I finish it this off and we'll have it in question section?
Yeah, sure. Thanks, Deepika. Thank you.
Sorry. Okay.
That's fine. Thank you.
Okay. So Genesis block. So Genesis in the sense the origin point of something which is created. Like when the blockchain is created, if initially the first block in that chain is referred to as the Genesis block, or we call it as block 0. So based on that first block or block 0, the additional blocks are to be added, and that's where a chain of blocks are formed. In that case, there is no previous reference for that Genesis block because it is the first block, an initial block. So there is no previous reference for that initial block. And the components of a block, like a block not only contains the transactions about Bitcoin or Ethereum or whatever, but it contains some of the components also, like block size. It is the size limit of the block, like only a specific amount of information can be written on it. The next one is block header. It contains the information about that particular block. Then the transaction counter, it is actually a count, or like how many transactions were stored in that block. And the transactions, it will have the list of transactions within that block. And the version, like cryptography, like cryptocurrency version which is being used. And previous block hash. Each and every block except genesis block will have a previous block hash in that current block also. So in that case, previous block hash will be stored in that. And current block hash, each and every block will have its own current hash. And the time, a timestamp to place the block in that blockchain. And the nonce is abbreviated as number only used once. It is an encrypted number that a miners will be solving to verify a block and close it. So we were seeing the aspects and components of a block and all. So how does this technology works? So the first element is transaction. Whenever two parties A and B are decided to exchange a unit of value, like it may be a digital currency or a digital representation of some other assets, and they will be initiating the transaction. That transaction is packed with other pending transactions. So there will be many even a block contain many number of transactions. So that's where other pending transactions are packaged together with that particular transaction. And that block is sent to the blockchain system of network. And then verification will be the participating computers evaluating the transaction. Here the participating computers are called as nodes, which I said earlier. So the nodes will be evaluating the transactions through some mathematical calculations. Then they will be coming upon this like they are agreeing upon the rules, and they will be sending the block into that blockchain. When that consensus has been achieved, typically among 51% of participating computers should achieve and should valid and should agree upon the rules. And after that, hashing. Each verified block of transactions is time stamped with a cryptographic hash. So as I said earlier, each and every block will contain the current block hash and also the previous block hash for the connectivity. So each block will have the reference to the previous block hash. So that's where a chain of records can be created. So the next one will be execution. The final thing will be the unit of value moves from the account of party A and to the party B. So types of blockchain. Public blockchain, like it is actually permissionless. Anyone can join the network, read, write, or participate within the blockchain. So a public blockchain is decentralized, and it doesn't have any single authority who will look after the network or who will control the network. So it is typically an open network, and the data we put into the public blockchain are very much secure, as it is not we couldn't able to manipulate it because it is immutable. The next one will be private blockchain. A private blockchain is managed by a set of administrators. And if any node should need to join into that particular network, will have the consent by the network administrator. It is a permissioned blockchain. And here only the participating entity will have the information about the transaction. Unlike public blockchain, in the case of public blockchain, anyone can read, write, or every people who are into the network will have the access. But in the case of private blockchain, if someone are someone are doing the transaction, someone are mining the blocks, then they only have the access to view the transactions, which means the transactions here are very much private. And proof of work. Before getting into this, I would like to say about consensus algorithms. So I have said earlier, like consensus is a general agreement between the nodes. Like majority of nodes will be participating into the blockchain network. So all the nodes will agree upon the consensus, and after that only a block is mined and added to the blockchain. So here proof of work, POW, which is actually a consensus mechanism used to confirm and record cryptocurrency transactions. Here the work, like the proof of work in this case, is generating a hash. All the miners who are participating in that network will be generating a hash, which is a long string of characters that will be matched with the target hash, which is given by the proof of work protocol network. So whoever, or a group of people, group of miners who wins that right, will be add will have the right to add that particular block to the blockchain, and that miner will be receiving the rewards. So this is actually consensus mechanism, and we call it as proof of work. And then proof of stake, it is also a consensus mechanism. Like here all the miners, here we call it as stakers, they will have their own cryptocurrency, they will stake their cryptocurrency, and they will be creating their own validator nodes. So when a block of transactions is ready, that proof of stake protocol will choose a group of validator or validator node to review that particular block. So the validator or the staker will be checking the transactions are accurate. If it is accurate, that particular block will be added to the blockchain, and that validator or group of validator will be receiving crypto rewards for their contribution. But what if they proposed, or if a validator proposed a falsified block, or an inaccurate information, they will lose some of their staked holdings as the penalty. So here are the consensus mechanism. So from here I have completed my part.